Morning, everyone. So today I'm going to be speaking about computing genomics with AI. So this is what we have on today's agenda. So moving on, I would like to have a brief introduction on this very diverse topic. I'd like to believe that everybody here has some type of understanding regarding machine learning as well as AI to some certain extent. After all, we are a software development company. These two aspects of the fourth industrial revolution play a very vital role in computing genomics. People always assume that AI, machine learning, robotics, and metadata only have an impact in changing the technological world, but this is not really true. Allow me to expand on this into more detail. Firstly, I'd like to break down this phase. What is genomics? Genomics can be defined as a geological study of the total or a segment of the genetic sequence information of organisms and attempts to understand the structure as well as the function. I think everybody's wondering, what does molecules and biology have to do with the technological world? This is where computing genomics with AI comes into play. Genomics with AI is a very complex phase of just defining a new way and finding possibilities of genome sequencing workflows. Today, I'd just like to focus on facial analysis regarding this topic. Facial analysis is just a way of examining people's faces using AI to accurately identify genetic disorders. Many genetic syndromes have a distant facial dysformia and facial disorders that can be used as a diagnostic tool in recognizing a syndrome. Facial recognition technology has advanced in recent years, and the screening of these genetic syndromes by facial recognition technology has become more feasible. With the development of the next generation sequencing, genetic research is becoming much more extensive, as well as the examination is considered to be a golden standard method. A study was recently conducted by the University of Oxford, whereby frontal facial photos were collected of about 456 children, both healthy and those with genetic disorders. This study had a higher result than expected of about 0.8% of being correctly diagnosed. In the present study, we developed a facial recognition model based on the VGG16 architecture from the Oxford University for identifying any genetic disorders from these healthy children, and the performance of a model was also evaluated. Facial recognition technology has been widely applied in various fields, and AI has integrated into routine clinical practices, specifically for diagnostic support. With the recent advancements of the CNN screening and diagnosis of genetic syndromes through facial feature recognition has become possible. Now, I would just like to summarize my takeaway today, that I believe that everyone can take something home from this. I think it's safe to say that AI, as well as machine learning, has a much more bigger impact than we actually think, not only in the technological world, but as well as other fields. Now, it also raises the question is that, will this replace our doctors in the future to a certain extent or not? Thank you.